morning. Okay, cool. So I think Amit's talk was pretty great in terms of covering what we should do as students, as early stage professionals, etc. I'm going to cover, once you actually do that, like what the life looks like, right, in real world. So I'm going to cover a couple of stories. So quickly before that, about me, I'm Chinmay. I go by Chinmay 185 on pretty much all social media. I am a founder and CEO at 1-2N. We work on site reliability engineering, backend engineering, etc. And I write these stories. I've been writing them on Twitter, LinkedIn, etc. primarily in text format. The idea of today's talk is cover to a couple of stories in a sort of story format, narrative format. And I like engineering, psychology, and who here knows this game? Okay. So this is a game I love. This is called Age of Empires 2. But yeah, if we should talk about that later together. So what I want to cover today is hopefully 3 stories if we get time for all 3, otherwise probably 2. And all of these are from real world experiences and exposure, right? And these are some sort of debugging stories. So imagine you deploy something on production and it doesn't work as expected. How do you go about debugging that? What are some experiences? What are some experiences from engineering managers or tech leads, from engineers? We'll try to cover some of that. So you join a team as a tech lead, and on the first week of your joining, the CTO tells you this: hey, our video processing API is broken. It's very slow, looks like. And last time we checked, it was a problem with AWS's EFS service. Can you go and check? Right? That's what the first statement that comes to. You're like, okay, let me think. What do I do? So you check the AWS EFS UI. You try to see, is there any problem? Doesn't seem to be. You check AWS CloudWatch. By the way, who here has worked in somewhat of an infrastructure, cloud, SRE, reliability, that kind of side? Okay, a few people. So I'll try to, for those who haven't, I'll still try to make it related to software engineering. So essentially, we've deployed something, it doesn't work as expected, it's slow, and your job is to debug and find performance issues, right? That's what this story is. Now, what you find out on AWS is that there is 12 EC2 instances or 12 virtual machines, and on which this giant 2 terabyte of EFS is mounted. And you're like, okay, how do I debug? Like, it doesn't seem to have any problem. What do I do now? So next is you say, hey, let me try and find the latencies. Like when CTO says things are slow, just how slow things are. Like, let me try to find that out. Now, you try to do that, but then, well, there is no easy way to get this data. There's no observability in place. So what you do is you try to say, okay, let me actually try to log on to each of the EC2 instances. And if there's any Nginx logs or things, I'll try to check those. So you try to check these Nginx logs and you try to find out what it takes, like what are the latencies that we're talking about, right? And there you see some latencies. I don't know if you can see that. This is probably say 800 milliseconds for the same API. And in some cases it shows 8 seconds. In some cases it shows 10 seconds. So like, what's wrong? Like, why is there different latencies for the same API? And why is there such a variance, right? You're thinking. Now, you think maybe just by looking at the system, you can't find purely from an infrastructure point. So you think, hey, let me try to take a look at the code to see what the code is actually doing so that I can try to find some common problems. So you try to look at the code, but the code is a bit complex to understand. There is no test cases, there is no documentation, and you're just looking at the code from the API point of view. You're going to the controller, the business logic, the repo, etc. And what you find the code does is it reads a bunch of files. Again, this is video processing API, imagine. So what they're trying to do essentially is, imagine a Zoom or a Google Meet or some sort of meeting like that. You get chunks of videos, small videos, 10 second each, 5 second each, etc. And you're trying to read all of them and you're trying to combine them in a larger, longer video, and they write this bigger chunk in EFS. right? That's what the code is actually doing. That's what you try to find out. And you're like, okay, this code is reading a bunch of data from EFS. It's combining all those files using FFmpeg open source tool, and then it's trying to write them all back to the EFS again. Surely, like, that must be the problem, right? Like, this is definitely the problem, because it's doing a bunch of IO, it's doing a lot of writing of files and whatnot. Yeah, I think I found the problem. But then, to your surprise, you see that this only takes a few milliseconds. This is not really contributing to the 8 seconds or 10 seconds of the latencies. You're thinking, like, what's wrong? Any idea so far from anyone, like, what could be wrong? Okay, we will come back to the story. So you take another look at the code. You think, this is clearly not the problem. The writing is not the problem. So where in the code we're actually getting all this latency from? Because there is no observability, we talked about printf debugging. So that's what you end up doing for now, at least to start with. And you see that the code marks some rows at the end of the function as processed. And it marks these rows as processed in the database. Right? That's what the code is trying to do. And you're thinking, okay, there's some table that is being updated with some rows, like some repo call. I don't know if, let me check if what's the time it takes, right? So again, you write some more printf statements and you try to find out, and you see that, wow, like that takes 8 seconds. Just a database update takes 8 seconds, 10 seconds in some cases. So at least you found the culprit, but you're wondering why is database taking 8 seconds, and in some cases it only takes like 800 milliseconds, or the whole API latency is still 800 milliseconds, right? You're still not sure. So you don't know the database schema design that well. So in a DBA, you go to Anju and say, hey Anju, I need your help with some DB schema design, etc. And she says, yeah, sure. Like, what do you want to know? So you show her the code and you check, do you know anything about this code? What is this doing, etc. So what Anju tells you is that, well, there is a background worker that we are also running, which touches the same table as this code does. I don't know when that worker runs, but when that worker runs, it is going to run some stored procedure query directly on the database. So that's what the code is doing. That's a different set of code, but it's touching the same tables that you are touching via the API. Now, and what that code does is it updates sort of some recent rows. Like, that's what I know. I have inherited this store procedure myself. Like I think Amit talked about a lot of code that you have to read that's written by someone else. So you try to read that code and you try to find that out. And what you realize is that there is some config for this code, right? It's called processing delay. And like, okay, let me go deep into that config. Let me try to understand what that config is and what that does. What you find is that ultimately that the stored procedure code and your API code, they're causing a log contention on the database, right? So again, you'll try to log into database, you try to get stats about logs, advisory logs, etc. And you try to find that, hey, it looks like there is a log contention between, on this table. And that's probably because there is a stored procedure running in the background, as well as this API trying to update the same set of rows. You're still not really sure about the root cause, and you've tried to find this processing delay, but you're not sure how it impacts. Some time passes, some other team members join in as well. And what you find is that the processing delay, these are the values, right? On production, you have a value of 1 second as a config. And on your staging or other environments, you have 300 seconds. So that's like 5 minutes, 5 or 6 minutes, right? Now, you're not really sure why, again, there's such a change in the config. Why does the production have 1 second? And what even it means to have this processing delay? So you try to, again, identify a few more things. And you try to ask, people, hey, like, you said this API is slow, but how long has it been slow? Like, is it always been the case? Did it fail recently? Stuff like that, right? So, what you get is, yeah, the customers reported that things are slow. Again, which is not the ideal place you want to be, but that's where you are right now. So you go deep into all of this and you kind of find out that ultimately the problem was the local config that was supposed to be there. So locally, when developers work on things, they have a config for processing delay, which is 1 second. and that config somehow got updated or pushed on production. And you fix the config change. What that config does is essentially it tells your stored procedure how long it has to wait till it again updates the bunch of rows. So it has to wait for 300 seconds before it can update the recent rows. That way this minimizes the contention. But then somehow locally the config is 1 second, that is usually just used for testing because there is not much of data, and that got pushed to production. So that's the real problem. So you fix the config change and you see, yeah, immediately latency start to go to sub millisecond, and things are kind of working, all jobs are completed, like everybody's happy. It took you few kind of hours to actually dig through and debug this system, but ultimately you got the issue fixed. Now, again, if you think about it, what we started out with, right? We said, hey, looks like AWS EFS is a problem. We started debugging some culprit. Maybe AWS EFS is the problem. Then we said, okay, how do we debug that? Then we went into tailing Nginx logs and trying to find out some problem from there. Then we went to reading the code. Then we went to going through the database and trying to identify stored procedures. And ultimately we landed on the config file change as a problem. What it tells you is that real life debugging is sort of pretty messy, right? And that's where I think the point I want to make is that you cannot be focused only on, okay, I'm just a front-end engineer, I'm just a back-end engineer, or I'm just a product manager, right? You have to be able to think as a detective and be able to go through each of the systems to be able to debug something, because that requires understanding the system end to end and being able to open the layer of a database or any API and to be able to go into it to understand what it does. So that's something that I would like you to take away. So in terms of lessons, what we ended up doing after that is investing in observability. So instead of customers telling us things are breaking, we should be able to find out things are breaking and alert them ourselves before. Second thing is what my personal experience has been. There is set of known failures with respect to systems, right? Like it's either a database, missing index, stuff like that, or it is a config change typically. Sometimes it's also DNS. That's again a very common problem. But you kind of try to find these things and you add versioning for all of these cases. Think about when the deployment happens, checking sanity, etc., stuff like that. And you've kind of seen these problems before, so you're able to imagine and you're able to say that, I mean, I've seen this problem before, so most likely let me check if those are the culprits that initially that you think of, right? So that's one story. Second, you are an SRE and you get woken up at 5 a.m. in the morning because of a AWS billing alarm, right? So you set up alarms, like who here has had that, by the way, happen to them? Not billing alarm, but like, okay, I see a few hands. Yeah, few hands. So billing alarms you have configured to make sure, if the bill rises by a certain amount threshold, you get paged alerted, right? So one fine day at 5 a.m., again, this is a different team, you join that team and you're on call that week and you get paged at 5 a.m. You're like, okay, what's this at this time, right? What you find out is that looks like a billing alarm, like this has never happened before. You've gotten woken up by latency alarms and stuff like that, like things crashing, etc. What you realize is that there is also the AWS support and EC2 abuse warning that has come up, which is first time you're seeing something like that. You're not really sure what does that mean and how do you resolve it. So you try to identify what's going on with AWS, right? What you see is that there's a bunch of Lambda functions that are running on various AWS region. Like you've never deployed your code on that region, but you see like some random Lambda function running in that region. And you're not really sure, like, what's this Lambda function? Like, who's this user? How and why is it running? You have all these questions and you're not really sure of any of these answers. Because this is like, is there some new service or new component that we wanted to deploy that I was not aware of? You have so many questions, right? So you try to rope in a development team member and to try to check with them saying, hey, do you know about this? what's the problem, yeah, or have you seen this function, stuff like that. What you get is that even they don't know. They're sure that this is not the code that we wrote. We have never deployed this function. Like, again, they're also not sure themselves, so they ask their other team members. Ultimately, after some time, you decide that, hey, like, we are not running this Lambda. I don't even know what that Lambda does. So just kill it. So you decide to say, okay, are you sure? Yeah, I'm sure. Like, just go and kill it. So you try to stop these Lambda functions. As you do that, what you realize, what has just happened, is that your AWS access credentials have leaked, right? And you try to find out from the Lambdas, like, what credentials they're using, what user they're using. You try to go to their permissions and stuff like that, and then you realize that, hey, these users have been created by a common access key, secret key, which has global permissions. Again, something that you should not do, but well, you have inherited that, so you have that. So there is like a distributed denial of service attack that's happening, and the attacker is running a lot of scripts to actually launch these Lambda functions. That's the problem, and you basically compromise your access and secret key, right? Now you are in a panic mode. You are like, okay, this probably, like, I don't know how many people have had their database got hacked or any of their cloud got hacked. I mean, feel free to raise hand. Okay, a few. Cool. So you hopefully learn something today. Then what you end up doing then is like, okay, I need to disable these keys fast. I need to stop all this infrastructure. So you're kind of panicking, and you're trying to make sure things are stopped, and you revoke the access key and secret key. Because of that revocation, a lot of things change on the software. Like, things break, your legit APIs break and stuff like that, and you kind of trying to go and fix them one by one, right? So it takes a few hours, but ultimately you've finally gotten rid of that access key. You revoke the permission, so no more attacks or no more Lambda functions or stuff running. So what you see, like, this is again a story that has happened, which is, it's not talked about a lot because it's harder to share failure stories, right? But I want to share that here because you need to learn, like, everyone needs to learn these lessons, that there is, whenever you work with cloud, right, the default options are almost like too easy for you to either get locked in, or they are sometimes pretty simple for you to shoot yourself in the foot if you don't know what you're doing, right? So there are some fundamental things that you have to learn when you work with any cloud infrastructure, right? So some things like role-based access control, your stricter security groups, nothing running on public cloud infrastructure, stuff like that, right? So that is something that you have to learn to take care of as you work on cloud. So I think that's the second incident that I wanted to share. And lastly, I'll talk about a third incident, which is not necessarily very tech oriented, but it covers the hygiene or the best practice, or how we should operate as engineers, right? So meet Sam and meet Radha. Radha is just back from a vacation, and she's the tech lead for this team. And Sam and Radha, you can see from their expressions, they're not sort of happy. So why not? So Sam says, hey, Radha, like, there's a stand-up that's happening as she returns, and Sam says, well, I'm blocked. Like, I'm not able to deliver anything for the last 3-4 days because, well, I don't have access to some credentials, right? And Radha says, okay, have you tried to raise with the team? Like, I mean, have you done anything? And yeah, I've sent an email, I followed up, but the process takes time. I don't have keys or whatever, so I'm not able to do anything. Radha is like, like, what are you really trying to do? Like, what do you need the credentials for? So Sam says, yeah, I'm trying to write a script that takes some data and is going to, there is a zip file or a tar file that's on some EC2 machine. I want to do some processing, and I want to upload that file ultimately on the on S3. That's the task that I'm working on. And Radha thinks, okay, but like, I mean, I get it, but why do you need credentials for that? Like, can't you build something locally? How far along are you with the script? And he's not able to get started because, well, he thinks like, yeah, I'm blocked, right? So then she asks, why do you think you are blocked? Why can't you work on it on your local machine? And Sam is kind of confused initially, like how can you do something locally? Like I can't, I mean, I have to connect to the machine, right? Like I have to write the code on that EC2 machine because the file is there. How do I access that file from local? Like I don't have credentials. That's the problem. And like, has anyone faced this situation? Like, have you had to, okay, a couple of people, okay. So Radha is still confused, like, what do you mean how? Like, in her mind, things are pretty easy and clear, and she sees that Sam is struggling with understanding what she's saying. So then they go up to a whiteboard, and she tries to explain, and she tries to have a dialogue with him, right? So the dialogue goes something like this, right? So Radha asks, what are you trying to do, right? Like, I'm trying to write a script which will take some data from that EC2 machine and will do some processing and then upload to S3. Okay, so why can't you download that file, or do you have that file locally? Well, no, that's I don't have that file because it's too big. Okay, like, how big is the file? Well, it's, I guess, 200 GB or something like that. That's too big, right? I can't download 200 GB of file. So how am I expect to write that script? I don't know. Then Radha says, okay, let's say you have some file. What are you trying to do with that file? Let's say I give you that file, right? What will you do with that file? Yeah, okay, so I have to extract that file into some structure. It's a tar file, so I'll extract that. And there's a bunch of data in multiple folders in that file. I need to extract some folders. I need to change some files, directories. I need to discard some data. I have some metadata that I'm operating with. Based on that, I'll discard some data. And essentially, I'm going to create a new set of folder hierarchy, and I'm going to tar that file again, and I'm going to upload that to S3. So essentially, I'm sort of reading some data, modifying it, and then uploading it to S3 again. So rather, like, do you know the file structure or the folder structure that's there that you need to read from a tar file? Yeah, I know that. Like, yeah, I mean, I know that structure. So then, but where are you going with this? Like, I'm not able to still understand. Sam is still confused. So Radha breaks it down for him and says, look, you can simulate a file locally, right? You can create whatever folder structure that you know, create that file locally with the exact same folder structure, create a tar out of it, write a script completely local. You don't need AWS, you don't need any account, and you're going to write the shell script or Python or whatever script that you want to write, extract the file, redo the mapping of internal file structure, folder structure, etc., and then create a zip or a tar out of it, and then you upload to S3. Couldn't you have done that? Then Sam says, yeah, but I still, like, why can't I get credentials? Like, why is it so hard to get credentials? Again, Radha has to sort of explain and tell him, look, how things work. You have to really understand what you are doing, right? And what I'm trying to convey here as part of this story is that most of the time when we say we are blocked or we are waiting for this data from other team or something like that, most of the time what I've seen is that that's really not the case, right? We could always simulate things locally. We could always use a mock API. We could always write a test case. We could always assume something and make our assumptions explicit, and then plug in the keys, the environment variables, the configs later whenever we want to, right? So idea is to build as much local setup as possible so that you are able to work on things independently of other, right? And the good idea about local setup is that any new developer joins a team, they're also able to set up with hopefully one click using make files or whatever to be able to set up the whole stack again locally, right? So at 1-to-N, what we call it as airplane mode development. So imagine you are flying in an airplane and you are, there's no Wi-Fi and you still have to work on your code, right? So are you able to do that? as much as possible, if you could do that, if you could set up code and systems like that, that will make life much more easier for you and the rest of the team members. So Sam understands that, and he goes and implements the script like this, and surely, like, whenever the credential request is approved, the script works as expected, right? So one last thing, I think the point that I want to talk about related to FOSS and open source as well is the whole idea of Unix philosophy. Like lot of software principles that we talk about these days are covered beautifully in probably 1980s, 70s. I think this was written, and this is what it is. You should go and Google Unix philosophy and what it means, but essentially it's a set of guidelines, principles, or ideas that you could actually use when you build composable software, right? Which is what we end up doing today. I think, yeah, that's it from me. If you are looking to read and learn more, here's a website. Go check out various bootcamps that we have publicly available. Go try this out yourself. Would love to get your feedback from that. Some of these stories that I covered are also written in a text format there, so go and check that out. All right, thank you. Any questions? I think this was a too dense of a talk.
Whenever we develop anything, so we have this Scrum calls and war rooms, right? Where we discuss what kind of functionality needs to be developed, and there's always this conflict between tech lead and the persons who actually develop and estimates to be provided. So how do you deal with such kind of difficulties and convince your teammates for that?
Interesting. I think software estimation is by default like hard. It's really there is people have written things about why estimation is very hard, and why even the problem with estimations is that when somebody estimates, the person on the other side takes those estimates as gospel and says, okay, you said 2 days, now you have to do it in 2 days, right? So some way I like to make my estimations a bit more apparent and bit more clear is that here are the assumptions that I'm making. If these assumptions turn out to be right, I think in the best case we should be able to do it in 2 days. If one of those assumptions are wrong, maybe we will need to figure out how much time it takes. So I'm guessing between 2 to 4 days if you were to estimate in terms of time. People also estimate this in terms of story points, so that's also an option. And you kind of try to provide not a one estimate like a single number, but a range in case of a best case or in case of worst case. And at the same time, you try to make the assumptions very apparent and clear as to what you're assuming, right? And I'm assuming that there's this system which will give us this API by this time, and based on that, then I'll work on my things. And if it's completely provided to me, then I'll be able to do this in 2 days, 3 days. So make your assumptions, I think, explicit and call out a range of time instead of giving a single number. That way, people are able to sort of appreciate that. I think hopefully that answers. I think, yeah, I'm out of time. It looks like maybe one.
Yeah, sorry. Thank you for the talk. How do you build a culture of doing these kinds of retrospectives so that you can both share these things internally and then maybe actually share them publicly? Because I think that culture itself is important to be able to do this kind of work.
Yeah, I think for reliability engineering, the whole RCAs that we should do, which is called root cause analysis of problems. So every incident, what we try to do is every incident has to have an RCA so that you learn from it and you don't repeat the incidents again. So that is one. And in terms of culture, I think it also starts from one top down, as well as people should be able to feel the psychological safety to be able to speak up and talk about failures openly instead of being feared as judged or being labeled as a scapegoat. If there's a culture in the org that does label people as scapegoats and fires people who are like messengers, then it's very hard. But for mature orgs, if you have a culture of RCAs and talking about failures publicly, openly, with the intention of learning, then that works out pretty well. I hope that answers. Cool. All right. Thank you guys so much. Looking forward to interacting.